SwayamPrabha. Digital India. Educated India.
The next topic of discussion, we are getting into design for maintenance. This is a very new concept. People initially started with design for manufacturing, and in manufacturing you have part making, assembly. Then people started making design for assembly and disassembly. Now people have started talking about a new concept called design for maintenance. So, in this topic, we will go through an introduction, then importance of design for maintenance, factors affecting ease of maintenance, then maintenance element and concepts, corrective maintenance, then we will have preventive maintenance, maintenance of a degrading system, total productivity maintenance, design review for maintainability. So, these are the topics we will cover through this. So, introduction. When a system fails to perform as required, it is said to be repairable or maintainable. A car you buy and the car conks off after 10,000 kilometers, or a scooter you buy conks off at 10,000 kilometers, then the system would have been promised for 1 lakh kilometer, but now it has got conked off after 10,000 kilometers. Suppose if it is a manufacturing defect, the company pulls back and then gives replaces a new product to you. If it is your problem, that means to say a customer, when because of his driving performance, the performance has fallen down or the machine has conked off, then there is an option for maintenance. So, it is said to be repairable or maintainable. It can be maintained by a suitable methodology, and maintenance also cannot be done haphazardly. So, today what is happening is we have preventive maintenance, predictive maintenance, and even the maintenance today what they are saying is it has to be given a schedule and you have to follow that schedule, and in that schedule also it is not necessary that you should do 100% maintenance of all the parts. They try to divide, suppose if there are 100 spots where you have to look for maintenance, and in that also they try to rank them which is more frequently to fail, which fails very rarely. So, then the checking cycle also reduces for doing those parts which rarely fail. On top of it, there is a schedule which is given, what all schedule and a suitable protocol is given, what all and how should it be checked. So, it can be maintained by a suitable methodology, be it repair, overoiling or replacing the either manual or by automatic action. So, today what happens is many of the automotive sectors, what they do is after selling the scooter or car or even a truck, the agent keeps calling you at regular intervals of time and he says that, sir, your vehicle is prone for is a schedule now for going a maintenance check. So, in the maintenance check, generally they try to do oil maintenance, they used to check the engine performance, spark plug performance and all those things. Okay, that is scheduled, and in scheduled also there is a protocol what has to be checked and how, and while checking if they find out any untoward incidents, then they say, sir, please replace this. Okay. So, that is what is maintenance, repairable or maintainable. It is important therefore, that every effort be to reduce maintenance requirements for nearly introduced system and equipment. So, we would love to have zero maintenance, but many a times it might not be possible. So, as far as possible, try to extend the maintenance time. That means to say frequency of maintenance should be reduced drastically. Okay. This is what we are trying to say. Here if you look back, we have done this FMEA analysis, right. in that FMEA analysis also, what we try to do is we try to see which are the parts going to fail and how do you improvise their design, and after getting the points we reiterate and rerun the entire FMEA and then get to see the points, we compare it and then do it. So, this design for maintenance also is an offshoot, it moves off from FMEA and we look for this design for maintenance. So, these two are completely different, but I am just giving you an analogy. FMEA, here also you do failure mode effective analysis, and here what you do is you have design for maintenance. Okay? A very similar one, but it is not the same. So, standardized maintenance work management process. So, if it looks like this, I met with the production supervisor and prioritized the work. So, this is the maintenance job request, set job priority. So, this is what it is. So, it is for a preventive maintenance. Then what he does is he plans all the activities and then he schedules the activities and then he job executes, either he or through another one he does. And after job execution, he keys in what are all the components, he keys in the status of different parts of the machine, and that is used to hold the record. And if you go back and see design for assembly, disassembly, we said acquiring data from history, this is the place where they record the history. Okay. And then what all has to be charged, they charge, and what all has to be free, they give it free, and this is given to the customer. So, here if you see the production and the maintenance meet week to fix the schedule and the plant access. So, here what do I mean? The scooter agent calling you is based on the scheduling. Okay. Lastly, I met the maintenance supervisor and explained him the details. So, this is what is breakdown and then he does. He also tried to give the complimentary, and this fellow is very smart to analyze it. Okay. And then here if you see the planning action, so according to this planning action, so it also tries to plan the stores and other purchases which is to be done. So, then failure analysis, I already talked about you, reliability growth, and then what we do is we try to have strategic reviews and try to figure out why this is frequently failing, and if need based we try to introduce a better material property there, or we try to heat treat, or we try to do some modification in the geometry such that we meet out to the requirements. So, this is the maintenance and planning scheduling which is generally followed in a product. So, this is a standardized maintenance work management process. So, you have maintenance job request, then set job priorities, then you plan, then you schedule, then you execute, and then you start reporting it. This is KPI reporting. So, the importance of designing for maintenance is maintainability is the degree of facility with which an equipment or system is capable of being retained in or restored to serviceable operations. So, after doing this maintenance, we are trying to pull back the equipment to 100% efficiency. If not 100, we go stop at 90% efficiency. So, once you do maintenance, we are trying to pull back or improvise the system and try to achieve 100%. It is a function of part accessibility, interval configuration, use and repair environment, and the time, tool and training required to do an effective maintenance. See, earlier days when you are on travel, we always used to say, please check the radiator coolant whether it is full or not. Then they say, please check the oil level whether it is full or not. Then they say, please check the pressure in the tire is to the required specification or not. Today all those things are replaced by sensors. Okay. And now the sensors are also nowadays trying to tell us if a particular part has got worn and torn, that means to say a particular part is very rapidly wearing it out. So, there are sensors today which measure and directly tell us that please look into these particular points where there needs your attention. So, the maintenance, and once they say maintenance, today you also see it is a software based. So, it also displays what is the protocol to be followed to access that point and what all the points to be checked before we try to do any more big maintenance. Okay. The US Department of Defense defines maintainability as a characteristic of design and installation which is expressed as the probability that an event will conform to specified conditions within a given period of time when maintenance action is performed in accordance with the prescribed procedures and resources. So, maintenance should always be followed with the protocol. This protocol will try to, you do not follow a protocol, then that is not called as maintenance or design for maintenance. The protocol has to be displayed, and then you have to follow this protocol and then try to get your machine repaired. The factors affecting ease for maintenance. As far as design equipment for maintenance is concerned, it has been practiced more as an art than as a science. So, art means you do not have to have a set procedure. Science means you have a set procedure. For every action there is a question raised and a standard procedure or an explanation is given in science. In arts it need not be. So, that is what it is told. So, as far as the designing equipment for maintenance is concerned, it has been practiced as an art. Now, today this art has to change into a science. So, what do I do? How do I do? When do I do? And is this the best practice? All these things has to be spelt out. To the extent that it has evolved to a greater extent as a result of common sense than by means of scientific investigation. This science also has to be predominantly around common sense. It is worth noting in this context that maintenance perhaps is most expensive of all human machine system activities. Very, very important. Today, finding a person for repairing is next to impossible. It has become pretty expensive. For example, in your own house or in my own house, when there is a plumbing failure happened, so we have to wait for a plumber for 3 days, and the plumber who comes does half an hour job and gets the entire day's salary from us. So, that makes it very clear that maintenance, whoever does it, is more expensive. That is why today world has moved to the concept of use and throw. When we follow this use and throw concept, we are now concerned about sustainable manufacturing. So, when we throw, we have to make sure that we throw certain things which are not going to make any hazardous damage to the mother earth. This is because of the increasing need to perform maintenance activities and high and ever increasing cost of human labor. So, this is what it is. So, the factors affecting for ease of maintenance continuing, the criticality of equipments for sustainable production, cost of new equipment versus CDM cost of equipment downtime. So, all put together goes to factors for consideration of condition monitoring based maintenance management. So, then availability of standby redundancy, equipment duty cycle, and then effect of outage on environmental and surrounding. So, these are the 6 factors which affect the ease for maintenance. So, factors for consideration of condition monitoring based maintenance management. So, now what people are talking about, condition monitoring. What is the condition monitoring? Condition monitoring of the part where there is a wear and tear effect going to be there. So, you are trying to measure a part where there is going to be wear and tear, and at regular intervals you are going to tell me the status, how is the status going, and what was it before 10 minutes and how is it now. And today the softwares have become so powerful, it also gives you a speculation saying that it can behave like this, be very careful. Condition monitoring. Okay. So, that is condition monitoring. Condition monitoring can be for a compressor, condition monitoring can be for a car, condition monitoring for a cutting process, condition monitoring for refrigerator with air condition. Everywhere today there is condition monitoring, because the sensor technology has become more energy efficient and reliable. So, the criticality of the equipment, cost of new equipment, cost of equipment downtime, availability, equipment duty cycle, and effect of outrage on environmental and surrounding place. These are the 6 factors which are to be considered for condition monitoring. So, the maintenance elements, the maintenance element describe the maintenance concept and requirement of any system. It includes the analysis and verification of customer requirement. Look at it. Maintenance includes analysis and verification of customer requirement. The priority selection of each element depends on the particular requirement. Maintenance elements have interconnection among themselves. Okay. So, this is very important. Maintenance elements have interconnection. What are the corrective maintenance? Corrective maintenance is a reactive in nature. Every time a product or a system fails, repair or restoration must be followed to restore its operation. I am wearing a footwear, the footwear gives off. I take it to a cobbler, get it fixed. That is corrective maintenance. Okay. I have a pipe which is leaking. I have a computer which is not opening. Call an expert, he comes, repairs the system, makes it functional, go. That is corrective maintenance. That is reactive in nature. The following steps constitute corrective maintenance. Once the failure has been detected, it must be confirmed. Okay. If somebody says the tap is broken and without even seeing it, people try to communicate the message, that is not correct. You have to confirm, yes, there is a tap breakage happening. If the failure is not confirmed, the item generally is returned back to service. This no fault found problem leads to considerable wastage of time at significant cost. So, once you call a plumber and then he comes and says, oh, that is not a problem at all, and then still you have to pay that 500 rupees what he has done, and he has also wasted his time. So, the product availability, product maintainability and logistics delay. So, you have maintenanceability, repairability, serviceability. This is logistics delay and administrative delay. So, these are all factors of product for maintainability. So, this is the interrelationship between the maintenance elements, which I dealt 3 slides back. So, the maintenance element is preventive, corrective. Preventive means it is scheduled maintenance, inspection, condition monitoring and analysis is preventive. You just check at every half an hour, or when you go by train and once the train comes to a halt at a big station, immediately you will see a railway employee going around checking the temperature profile or the temperature at the wheels or at the suspension system. What is he doing? He is trying to see is there any temperature rise drastically, and then if it is drastic, he goes reports this, and then immediately necessary actions will be taken. So, scheduled maintenance, inspection, condition monitoring and analysis is preventive. Corrective is moment the failure has happened. So, the failure determination, failure isolation, failure repair, calibration and functional check are part of the tasks which is to be done. So, in a car also you try to figure out the motor of a car, whatever, the wiper motor conks off. So, you just strip off the wiper motor alone, take it to a shop, replace the motor and start going. That is corrective. You are isolating the system from the rest. Okay. Next is maintenance items. So, the maintenance elements can be policy, can be at times, location and procedure. So, maintenance time is preventive, servicing, inspection, replacement and overhauling. These are maintenance time. Corrective, it can be preparation, failure isolation, logistics, correction, adjustment and calibration. It can be stationary, that means to say field shops, maintenance labs, they all can be part of it. Okay. Then maintenance location, it can be mobile, it can be remote. Mobile is maintenance vehicle. Say for example, if you nowadays you see that you have tow vehicles which go around on the highways. So, the tow vehicles, you just give them a call number, they just give them a call, they come to the spot with all the kits, with all whatever it is required for that particular car, and then quickly they start working on it, set it right, give the bill on the spot, take it and then take the cash or take the money and then leave. Or the other way around is they tow you from the spot, bring it to the service station, work on it and put you back onto the main road. So, you can have maintenance location mobile, you can have maintenance location remote. Remote is today when you have all these big cars, big luxurious cars which are sold. So, all these cars have their service stations only at metros, for example, Chennai, Bombay, you might have in Delhi, and then maybe in Haryana. But suppose if somebody owns a luxurious car at a very eastern corner for somewhere in Tezpur he holds. So, he does not have a maintenance person to come all the way from Delhi to go to his place. So, that is what is called as remote locations. Then procedures, it can be documented guidelines, standards and specification. This can be in hardware, this can be in software, which can be shared or which can be transferred to the people. So, the maintenance environment can be the maintenance procedure, the maintenance environment, it should have temperature proof, vibration proof, shock proof, radiation proof, electromagnetic. When you are talking about sensors or when you are talking about electronic gadgets, EMI plays a very important role. The maintenance data is going to be from the conceptual stage you take it, design and development stage, you try to take the maintenance. That means to say, when you are trying to build a car, sir, when you are trying to build a car or trying to build a machine, when you have screws, you can always put the screws on top of the surface where you can access your screwdriver, access those screws with the screwdriver to remove a lid. You can also put it right at the bottom where in which you do not show these screws at all. When you put right at the bottom, the accessibility difficulty comes. When you put exactly on the spot or on his eyesight when it is visible, then that is going to hamper or that is going to make the entire product look little more uglier. So, you have to have a trade off in the design stage itself where to have these screws and bolts such that they can be fastened. The other way around is in the design stage itself you say, I hate these screws and bolts, let us have a press fit, shrink fit, done. So, it is in the design concept itself you should bring in from the maintenance data has to go from demonstration phase, from field in use phase, you take the maintenance data and then analytical calculations in the existing data bank. So, this is for trying to figure out what is the performance. Then maintenance personnel can be general trainee, specialist trainee, on the job trainee, updating trainee, and then skilled level and personal requirements. General trainers are people who can do any job, jack of all trades. Specialized trainers are turner, fitter, welder, they know only all about turning. On the job, I do not know anything even in turning, I can do only this job, that is on the job training. Updated training, till now I was a draftsman, now I realize the computers have come. So, I have taken a training of computer, I have updated myself and then I start doing it. Skill levels is also very important and the personal requirements. When you look at corrective maintenance, the item is prepared for maintenance if the failure is confirmed and then the failure report is complete. So, in US or in even developed countries or in costlier automotive things, they always make a sheet which says serial number, it says defect and then they say remarks and then they will have one more column, they say who is responsible. So, then he starts looking at the product and then he starts writing down the defects. And in fact, in certain cases, they also give a space where in which you can draw the part and then try to mark which all locations the defective has happened. And then try to write your remarks and then say who takes the responsibility in fixing it. And then if you still want, you can also have, you can give them what is the time that they have to fix and then give back. So, localization and isolation of the failure parts in the assembly is the natural next step or corrective. The failed part is removed for disposal and the item may be reassembled so that it can put back into working conditions. Preventive maintenance, predictive maintenance. I have just put the full example. So, imagine your purchase, imagine you purchased a new economic car 3 months ago. To get around, you alternate between riding a bike, walking and driving your car. So, in 3 months, since you have owned the car, you have driven about 1000 miles on it. However, the car manual says to get the oil replaced every 3 months or 3000 miles. So, now the company has already pre-scheduled, assuming that in 3 months time you will go 3000 miles. 3000 miles in 3 months divided by 100, it's a day you will go 30 miles. I am staying in a campus where my house and my office is hardly a kilometer away. So, if I have a car and if I have to use the car, I go morning, come back for lunch, go to the office and then come back for dinner. So, I go 4 times, maybe this 4 can become 6 times or 8 times a day. So, 8 kilometers a day I go. So, if I wanted to even touch 1000 kilometers, so 8 divided by 8, it naturally takes me almost, so 100 divided by 8, I said 1000 divided by 8, so it is 16 times. So, 12, so 96, 40, so 125. So, it takes me 125 days and it's all 125 days I do not go. So, it is all Saturday, Sunday coming in between. So, it becomes almost. So, now the company, by taking a data from so many people and knowing their performance of the engine and all, they say please replace the oil within the first 3 months time or this. Since it has been 3 months, you dutifully take your car to the shop for a costly oil change that is supposed to keep your car running in a great condition. This is an example for preventive maintenance. Understood? So, a schedule is given, do or die, you go to the shop or you go to the repair shop, throw your vehicle, dump your vehicle there, get everything replaced, pay that money and then come back. So, that is preventive maintenance. If you logically say I have only travelled 100 kilometers as against 1000 over 3 months time, so should I still do it? So, now the company says okay, if you do not want, our scheduled thing is to do 4 times free service. I remove one of the free service, you come for the next time, I will do whatever I can do. That is what is it. So, this is preventive maintenance. But suppose if your vehicle is running for a long time, maybe 10 years is over. Now, this 3 months time plays a very important role. Every 3 months you go to the mechanic shop and show it to him, get yourself assisted, because your vehicle has your vehicle is moving towards old age. So, it is 10 years passed by. So, that is preventive. So, preventive for a new vehicle is a different impact. Preventive for a 10-year-old vehicle has a different impact. Let us now move to predictive maintenance. Now, imagine you own a luxury car, maybe a BMW, that is equipped with condition based service indicator for your engine oil and air filter among the parts. You drive the car 6 months, put around 5000 miles on it, and then an alert comes on that say you have 500 miles left before you must change the oil. This is an example for predictive maintenance. So, what happens here is you have put sensors. These sensors maybe weighs or it has a vision based sensor. It sees once the color changes, when it is becoming dark in color. So, it quickly comes and tells you, boss, now it has become very dark or very black in color. So, now you have to go for replacement or do some corrections, and it is not right now you go, we will give you some more time, we will give you another 1 more month or 15 more days. By that time, please make sure it goes. So, it is called as predictive maintenance. So, preventive maintenance is triggered by time, event, meter reading. On the other hand, predictive maintenance is based on actual condition of the equipment rather than time and age factor. So, equipment's condition. So, failure indicates. So, if you say predictive, preventive, predictive, preventive, run to failure, this is the time period. Okay. So, this is called as predictive. In predictive, you have failure indicates and here is a technique, ultrasonic technique, which is used for detecting the failure. Then in preventive, we always try to have vibration detection, oil analysis detection, we do it, and once it crosses this time limit, then what we do is we use acoustics, we use temperature, we use mechanical loss, we use auxiliary damage, and then finally we look at the catastrophic failure. So these are the things which happen. So here the failure is indicative. So that is predictive. Preventive is ultrasonic detection and vibration, it is preventive, and run to failure is you will have audio. So suppose you keep running a car and over a period of time you say all of a sudden there is a sound which comes out. So you say, okay, something is wrong, I hear a new sound. So then you go to the mechanic and say, this is what is the sound I hear. So based upon your interpretation, then he starts working on it to give towards a solution. So what are the benefits and what are the limitations? Full product visibility, cost effective, preventive. Predictive with when will failure occur, improved product life cycle and downtime is reduced. Limitation requires condition monitoring and skilled based staff. Saves energy, predictive, saves energy and resource, cost effective, it is effective, efficient productivity, redundancy of unplanned downtime. So all these things are part of benefits, and these are the limitations. So maintenance of a degrading system. Degrading system is a human body is also degrading, sir. For example, when you are born, you have been given the best flexibility, but over a period of time this flexibility is killed and you become more and more and more rigid. Let it be even your spinal cord, the sitting posture, the fitness what we have, it is all like degrading of a system. So most system operates with some sort of degradation occurring throughout their useful life. A review has been done periodically to determine what action need to be taken to enable the maintenance of such system. To optimize the maintenance schedule, it has been suggested that the level of degradation be monitored instead of time. So this is degradation, this is the time. So degradation happens like this. They say please don't look at the time, but look at the life sacrifice or the damage which is getting induced to the piece more than the time. This approach enables the additional of factors such as maintenance cost and distribution of degradation. Aggressive maintenance. Aggressive maintenance implies a much more aggressive and far-seeking maintenance philosophy than preventive maintenance. In aggressive maintenance strategy seeks to improve overall equipment operation, drawing on the concept of total productivity maintenance. Okay. So this is little bit more than preventive maintenance. So what is total productive maintenance? Total TPM, total productivity management, is also the total productivity maintenance. So here we talk about total productivity maintenance is a system of maintaining and improving the integrity of the production and the quality system through machines, equipment, process and employment that adds business value to the organization. So it's a system of maintaining and improving the integrity of the production and quality system. Maintaining and improving the integrity. Integrity means it is a holistic approach. Okay. So it can be through machines, equipments, process and employees it can be done. So the TPM goal is zero defect, zero breakdown, zero accident. So it's all in zero is going to be TPM goal. Zero defects, zero breakdown and zero accidents. So you have autonomous maintenance should be there, planned maintenance should be there, you should have focused improvement should be there, early equipment management should be there, quality maintenance should be there, then education and training system should be there, TPM in the offline platform should be there, safety and environmental management also should be there. Basically they try to say 5S and visual management system has to be there. So these are all the building blocks or pillars for achieving the TPM goal of zero defects, zero breakdown and zero accidents. So design review for maintainability, the quantitative and qualitative examination of the proposed design to ensure that it is safe and has optimal performance with respect to maintainability, reliability and performance variables need to specify the equipment. So, this is a definition which is given by Thomson. It is usual and necessary to undertake a review about the 4 principal levels of design. Design specification review includes market need in the product design, system review, equipment evaluation and the component analysis. These are the 4 principal levels of design. Okay, these are all for review. So, the objective of the design specification review to make certain that all parts and specification are understood at the outset and importance of different statements is appreciated. Reviewer of the design specification to ensure that the specification of all the point containing within the design specification are understood prior to the commencement of any design activity. Activity system level review. So, these are all the different reviews we done. Equipment to evaluate quantitatively critical items of equipments. So, these are the equipments and these are the component level design review techniques. System review is also part of that. So, here it was defined design review, design specification for design for maintenance. Then system review, for planning a system review, a peer reviewer obtains an understanding of the firm's accounting auditing practice such that the industry of as the industries of its clients are. The design of the firm's system includes its policies and procedures, how the firm checks itself that it is complying with them. So, the system is supposed to make a car. So, the car has to have certain specification. How good is your manufacturing and how did you meet the specification? The reviewer accesses the risk level implicit within different aspects of the firm's practice and its system. So, with this we come to an end to this lecture. So, task for students. So, what we will do is you try to look at a product. Let us try to take your scooter, sir. Try to understand preventive maintenance, predictive maintenance, corrective maintenance, system maintenance. Okay. You try to figure out what type of preventive maintenance, what type of predictive maintenance, what type of corrective maintenance are going on in your scooter, and finally your system maintenance also. Then you will also try to appreciate how your scooter performance was before giving it to repair and then after. Okay. So, you will see how because of this maintenance how is the performance getting enhanced. Okay. Thank you very much.